Hello guys, this is CodeNCode and this is third lecture of Java design patterns. In this lecture, we are going to cover prototype pattern, which is again one of the many creational design patterns. Right? Let's go ahead and see what is this, why do we need it, how to implement all of it. Right? So let's get started. So what is a prototype pattern? So it lets you copy existing objects without your code having to depend on their classes. Basically, it allows you to create copies of a given object, right? You might think this is a very simple thing, you can do it yourself, which is absolutely fine. But again, all of the design patterns that we are going to learn promote a lot of things, right? Like writing clean code and extensible code. So this is going to do the exact same thing. And also, there are many scenarios where you actually need to copy multiple objects, right? You have an object and you have to create a multiple object of out of it, or you are given a class and you want multiple copies or multiple objects of that class, right? So let's see why is it even necessary, how does it help, and what are the different applications of it, right? So that you'll understand the importance of prototype pattern. Right. So why do you need to copy any object? So there are multiple real world scenarios when you need to copy existing objects. For example, uh, my bad. Yeah. So this comes after you have established that yes, you need the copies of the object. So let's say you want to create copy of an object. You can do that, yeah, but that is a tedious task, right? And also a complex one. You might need to go through each and every field of that object and create a new object, take the old one, take every single field of that old object and copy into the new object, right? You can do that, but again, it's a tedious and complex task. Sometimes it is not even possible. For example, uh, the third point that I'm going to talk. Let's talk about the third point. So once you have created an object, it is possible that you are dealing with an object that has private fields, or getter methods are not available. So if you are creating a new copy of it, you can't get certain field of the old object. How you're going to set in the new one, right? If there are private fields or no getter method available, how you are going to perform the copy, right? And also, creating a new object is an expensive operation. There are many scenarios where this is actually an expensive operation. And let's say you have a scenario where you want multiple objects of the same class. If you go ahead and instantiate every single object, then again and again, it will be, of course, if instantiation of a single object is expensive, just imagine, you know, how expensive it would be to create like 20 copies of it. How can it be expensive? There are multiple scenarios. For example, let's say to instantiate an object, you need certain data from the network. So if you make a network call, network calls are expensive. It takes time. Or maybe you need to make a call to database to get certain fields of the object to initialize the object. These are the scenarios where creating a new object is actually expensive. And imagine if you have an object, right, and you need to have, like, let's say 20 or 50 20 or 30 or 50 copies of that. You might think, what are the scenarios when you actually need these many objects? Yes, you are developing a game, right? And then a player is there, and then there are multiple enemies, right? So just keep in mind that the enemies are actually copies of each other, right? So for each enemy to represent them, you need an object, right? When you're going through the code, each object represents one enemy, and in a game, enemies uh, keep on dying and keep on respawning, right? So what are you doing? Deleting the old object, creating new ones. So there are scenarios when you actually need to copy objects, or you have to create multiple copies of it. So if creating an object is expensive, creating multiple of it will be a lot more expensive, right? So that's why, instead of creating new one again and again, we could just take one object and copy it multiple times to create multiple instances of that, right? So creating a new object is an expensive operation. There are times when you are dealing with private fields, or there are no getter methods available. And also, if you want to directly copy, right, that means creating a new object, taking the old one, getting all the fields of it, and instantiating and setting the fields of the new one, you can do that. But this makes your code dependent on the other classes which you don't even want. For example, let's say you have a person class, right? So imported person class, you have the person object now, and you want to make a copy of it. How you're going to do that? Initialize all the fields of person object, right? Now person has an address also inside of it, right? To instantiate that field, you need to create a new address, right? New address. If you do that, your class, your code now also depends on the address class, right? So you have to import the address class as well. So this is just one example. There may be many other classes which you don't want your code to be dependent on, but your code will be dependent on them anyways if you want to create the copy of that object, right? So these are certain scenarios where where this prototype pattern actually help your code make it better, and of course a cleaner one, right? So now that we have established why do we need a prototype pattern, and we have seen certain scenarios where copying an object creates an issue, let's see how we can solve these, right? So the way prototype pattern solve these issues is prototype design pattern solve this issue by delegating the cloning process to the actual object that are being cloned. I have my own code, right? And then I got an object, I want copy of it. So instead of me doing all the job of creating a new object and setting the fields one by one, it should be responsibility of the class or the object itself being copied. That's exactly how prototype pattern solves it, right? So what it will do, it delegates the cloning process to the actual object being cloned, right? So basically what it does, on hindsight, it defines a common interface with a single method in uh, let's say clone, right? For all the classes that needs cloning, so you can implement that interface and define the override the clone method, right? This way. So it sounds very straightforward, which it is, right? So let's see how you can actually implement it. So as we are learning for Java, so I'll cover for Java specifically, also for other languages, right? There are two different ways you can actually implement prototype pattern. One, for Java, there is clonable interface directly available for us to use, right? So we'll see what is clonable interface, how you can use it to implement prototype pattern, right? We'll see what are the issues with this approach. Clonable interface comes with a lot of issues of its own, and how you can resolve the issues. So we'll implement a prototype pattern using the clonable interface available to us in Java. And also we'll implement the same using the copy constructor, right? This you can implement in any language. So yeah, let's have a look at the implementation of prototype pattern using clonable interface, also using the copy constructor, right? So let's get started with the implementation. All right, so let's get started with the implementation of prototype pattern. So as you can see, I have two packages, clonable and a copy constructor. So in here, I have implemented prototype pattern using the clonable interface. All right. So inside the main function, what I'm doing, I'm just calling this function which will perform the copy, and we'll see how it works. Right. So I have two classes, person and address, and inside person, I have two fields, string, name and address. So a person has a name and an address, right? Constructor getters and setter function overridden the toString function so that I can print the person object. And also I have overridden this. I'll explain this in a moment. So to implement prototype pattern or enabling copying of an object for a class, you implement clonable interface that is available in Java. First issue with this approach is that clonable interface is only a marker interface. That means it doesn't have any function inside of it. It only marks the person as clonable, right? That is one of the issues. So just because you have marked it doesn't mean your class supports cloning. For cloning, you have to override the clone method. Okay, inside of it, you will perform the copying, right? Cloning, yeah, copying, whatever you would like to call. So it throws clone not supported exception. That's why I'm throwing it here. So the way you do it, the way you copy it is simple. The way you clone it, just call super.clone, right? And then it returns an object that you can typecast into the object of this class. As simple as that. All right. So if I go here and see whether it works or not. So I have created a person, and using that person object, I have cloned it. So you see, cloning process becomes so much easier because now while using it, you are not responsible to create a clone, but this object is, right? Because we have added the business logic to clone here. So I don't have to go ahead and take each and every field and copy it into the new object. I don't have to do that. All I'm doing is calling a clone function, and I have a cloned object, right? Now I want to see if it is a valid clone. That means there are no issues. If I have created a clone of it, I don't want uh, these two to interact with each other. What do I mean by that? I don't want this to happen, that I change any field into the original object and it affects the cloned object. I don't want that, right? They should be separate two objects, right? So what I'm doing here, I'm printing the cloned object, then I'm changing the name in the original object, and then I'm printing the cloned object again. So if I just, yeah, comment it out, and if I try to run this, so if I go ahead and run this, let's see, does it impact or not? So if you see, this is the cloned object with name CodeNCode, address New Delhi, Delhi. I have changed the name of the original object, but it doesn't impact the cloned object, which is a good thing. But the issue comes here. Let me just run another example. So again, I'm printing the clone object. I'm changing address of the original object, and I'm going to see if it impacts the cloned object. All right. So if you run it, see here, it actually does impact. The address has changed from New Delhi to Old Delhi because I have changed a field into the original object. It has impacted the cloned object. Why is that? This is because the other issue that comes with clonable interface, it supports shallow copying, but didn't happen when we changed the name. That is because name is not a reference type variable, but address is. Address is a reference type variable, right? This is basically this has the reference to the address class object. Now, what happens when you have a reference type variable? So clone, what it does, it copies values one by one, and if you have a reference type variable, it just copies the reference of it. So clone person and person are actually referencing to the same object address. So if you change anything in the address, it will impact the other one, right? How you can resolve that? Simple. So you have to perform deep copy. How you do that? So any reference variable that you have to enable them for cloning also. That means in the address, as you can see, I have not implemented the clonable interface. So let's go ahead and do that. Implements clonable interface. And as I've explained earlier, just because I have implemented clonable interface, it means nothing. I have to override the clone method also. Done. So what I'm doing, again, calling super.clone, and it returns address. All right. Now, to enable deep copy, as of now, this super.clone only does the shallow copy. So save the address. Sorry, save the person. So person is equals to super.clone. Now that we have now that you have person object cloned, and we know this person object has again the same reference as the original one while cloning. So we have to perform deep copy. Deep copy will happen when you clone the address as well. So clone address as well. So person dot set address, and in here you can copy, right? So just call the clone method on address. All right. So just a second. Yeah, you come here, and from person dot get address, you have the address, right? And you have to clone this as well. Dot clone. My bad. Okay. So this way you are performing the deep copy. So you are taking the address, right? And it will have the same reference as the original one. So you have to create copy of that also. So that you can do using the clone method. So once you do that, you can return the add person, right? So now this cloned person have a cloned address as well. So this way you can perform deep copy. So you have to clone every single reference type variable and set in the person again. So this is deep copy, right? So if I change the address, we'll see that it won't impact the cloned address. See, I'm printing the cloned object, changing the address in the original object, printing the old object again. And as you can see, there is no impact on the cloned object. So this is the right way to perform cloning, or as we call it, deep copy, right? So this is how you can implement prototype pattern using the clonable interface, right? There's one more way you can implement you can implement prototype pattern using copy constructor. So as you can see, again, I have a main function, right? And I have two classes, vehicle and engine. Inside vehicle, I have model, brand, and also I have engine. As you can see, this is reference type variable, so we have to keep track of this also while copying. So this is the constructor and this is the copy constructor, right? Which takes a pattern and creates a copy of it. My bad. This takes my bad vehicle object, because this is a vehicle class, and creates a copy of it, right? Now, there are getters and setter method and show details function to show the details of the vehicle, right? And as you can see, this is the engine. And again, since vehicle has a reference type variable engine, we need to go to engine class also. And here also we have to perform deep copy, right? So this must also support cloning. And that's exactly what we are doing here using another copy constructor for engine class. It will take engine and copy the values from original object to the new one, right? So this is how you implement uh, deep cloning using copy constructor. Yeah, so you have the constructor, you have set both of the fields, right? And now you need to create a new engine, again using the copy constructor. This is your deep copy, and then set it to the engine also. If you don't create a new object, of course both will have the same reference, and that will create issues for us. So if you go ahead and run this, I have created one car, Toyota Camry, horsepower 200 for engine. I'm showing the details of first car, right? I have created a clone of it using copy constructor, right? Here I'm passing first car. Now I have car 2, which is basically cloned object, and I'm showing details of it, right? And here I'm going to modify the original object or the first object. Okay, let's modify details of first object and see if it impact the second object. So if we go ahead and run this, since we are doing it using copy constructor and using deep copy, it shouldn't impact it, right? So first of all, original and the clone both printed, original and clone both printed. After that, we are going to modify the engine. Yeah, I have modified engine of car 1, then I'm printing car 1 and car 2. So after modifying, you see car 1 horsepower has changed 250, but the second car's horsepower remain the same, the cloned object. That means it is working just as expected, and we have successfully implemented the prototype pattern using a copy constructor, right, with deep copy. So this is how you can implement prototype pattern using clonable interface or using deep copy. So this is it for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.